Okay, so what was the function again? The point, what function was 4 minus x squared?
Yes, and point was 0, 2.
Right, and if we wanted to just do a little sketch of this, we don't need to. It's really not important, but we could. There's the function and there's the point, right? We agree?
Yeah.
Okay. Point has coordinates 0, 2, and then we want to find the point on the function closest to that. So we're going to minimize distance, aren't we? Right? Okay, so then how are we going to set this up?
D squared.
Okay, right, so we're going to need, it's going to be a distance formula, isn't it? And we've got our sheet here. First thing we want to do is, well, we got this is our picture, right? If we want to have a picture, we don't even really need it, but we need a primary equation. Okay, so if we're going to have a point on here, what are the coordinates of the point on the function going to be?
An x and y value.
Just x and y, right? But they're variables. Now, they're going to be related by that function, right? By y equals 4 minus x squared. So that is actually our secondary equation, isn't it? We've got two variables here, x and y, and if we use the distance formula, we're going to have both x's and y's in our answer, but this is how y and x are related, right? Okay, so first things first though, let's go to step number 1. Step number 1 is we need a primary equation. So what's the quantity, and that has to involve the quantity that's being maximized or minimized, so distance, right? So we could say that distance squared equals what? Okay, so yeah, so it's going to be, if we draw a little slope triangle here, or a little triangle, this distance, that represents d, right? So what's that going to be? Well, that's just x minus 0. Everybody agree? So it's going to be x squared plus this distance right there, which is going to be y minus 2 squared. Everybody agree? Okay. You with me? And that's really just, if I want to put a square root on this, it's just the square root of x2 minus x1, right? X minus 0 squared plus y2, which is y, minus y1, which is 2 squared, right? Okay, but I'm not going to put a square root on it. Okay, I'm not going to put a square root on it because that makes this a much, much harder function to deal with, right? Then we've got another layer to our chain rule. Okay, this is the big trick I want to get at here. Are we trying to find the distance in this problem? We're not, are we? The question does not ask for the distance. It wants us to find the closest point on the function. It wants us to find the point that minimizes distance, but it never asks for the value of distance, right? So then why not? Why not pick a different, easier function that is also going to give us the same answer? You see that trick? That's a great trick, right? So let's call this d squared, so the square of distance, let's just call that capital D, right? But wouldn't you agree that the minimum of the square of distance is also going to be the same thing as the minimum of distance? Wouldn't you agree? Okay, when distance is minimized, its square will also be minimized, right? So then we're just going to call this, how about capital D is equal to x squared plus y minus 2 squared, and that's the function we want to minimize. Okay, but now this brings us to the bottom of step 2. If the primary equation involves only one independent variable, move directly to go and collect your $200. No, we go straight to step 4, but that's not the case here. If the primary equation involves two independent variables or two input variables, we need a secondary equation. Well, it does. D is a function of x and y, but looky here. There's the relationship, right? It's a function. A function is just a rule that relates input and output variables, right? So that's what we could plug in right there, right? Everybody get it? So then, we end up with d of x now. We're going to eliminate the y, is equal to x squared plus, well, y is going to be 4 minus x squared minus 2 squared, right? Everybody with me? Does that make sense? The y just became that. Okay, we good? So now we can sort of flip into, well, let's simplify this first, okay? And then we need to flip into calculus mode, making a table essentially, right? We're just gonna go through the steps that you're practicing with harder functions in 3-6, pulling it all together, right? So what's that gonna give us then? D of x equals, so this is gonna become, what's gonna be in the brackets here? This is just gonna end up being, yeah, 2 minus x squared, and we're gonna square that, right? So that's gonna give us x squared plus 4 minus 4x squared plus x to the 4th, right? Let's combine everything. So x to the 4th minus 4x squared plus x squared is minus 3x squared. Everybody agree? Plus 4. Everybody buy that? Check me. Did I do that right?
Well, just say it one more time.
So it's going to be, if I expand this out, I'm going to get 4 minus 4x squared.
Yeah, you're
The
right.
3x squared.
He's right.
Because I have to add that x squared to it. X squared plus negative 4x squared is negative 3x squared.
Oh.
And then plus my 4. Okay. And then, x to the 4th.
What? Is it, that's not the derivative.
No.
right?
No, I'm just simplifying. I'm just expanding, whoops, I forgot the square. I'm expanding that out and
Yeah.
adding that term to it.
Where's the 4?
Yeah, where do you get 4x squared?
It's 2 minus x squared times 2 minus x squared.
Right.
So it'd
Remember our
just be
rule?
negative x to the 4th, right? And then it'd also be 4.
No. No. That's not right.
Because if
Yeah, it's too different.
What's the quantity, what's the binomial expansion for that? A plus b squared is what?
A squared plus b squared?
No.
a squared plus
Oh.
ab plus b squared.
A squared plus 2ab plus b squared.
Oh, yeah, okay, that makes sense.
Okay? Okay, so there's our function, right? And now we're firmly in calculus mode now, right? And it may be, we can kind of almost lose track of what the problem is all about for the moment, because we're just trying to optimize this function, right? One more thing we gotta do though, the first step is always to find the domain of the function. Well, that's pretty easy. It's all reals, isn't it? There's no limit to what x can be. Right, so. Okay. Okay, so now we can start doing calculus. And this is easy calculus because it's a polynomial. When you see a polynomial in calculus, you just start slobbering because it's going to be easy work, right? There's not much going on there. What's d prime going to be?
4x minus 6x, or cubed,
4x cubed minus
6x.
6x, okay, good. And so while we're at it then, d double prime is 12x squared
This kind of.
minus 6. Okay, now all we're looking for here are just, see what I'm saying? The math is easy a lot of times. When you do real world problems, the math ends up being simple. It's just setting it up that's kind of the fun and challenging part. So all we're looking for are relative extrema, right? We're trying to find the minimum the absolute minimum on our domain, right? Which is all real, so it's going to be the global minimum, right? So we don't really need to find critical numbers of the second derivative. What good is it? Second derivative test. That's really why we need it, right? So when we make our table is going to be pretty small. So here's x, y, actually not y, it's d, isn't it?
Why it was weak.
Right? What are our critical numbers gonna be? Well, there's our first derivative. So what could we do? We could set that equal to 0, right? And solve. I can divide by 2, and then factor out an x. So I get 2x times, well, actually, hang on. I guess I can just take out an x then, can't I? Can't take out, well, I'll just take out a 2x and not divide by 2. So if I take out 2x, I'm left with 2x squared minus 3. Everybody agree? Okay, so what are my zeros going to be for that? Plus or minus
the square
square
root of
root of 3 halves? Okay, so everybody see that? Okay, so our domain is infinite. And we get the critical numbers 0 and square root of 3 halves and minus square root of 3 halves, right? Those are zeros of the first derivative. So all I've got to do is look at the second derivative test for each of those. Okay, well, here's my second derivative right here, right? What am I going to get at 0? What's the sign going to be? Negative. What's the sign going to be at negative square root of 3 halves? Well, square root of 3 halves squared is going to give me 3 halves. It's going to be positive, isn't it? Pretty clearly. That's going to be positive, and that's going to be positive. So what do we got going? Horizontal tangents. And this is going to be a minimum. This is going to be a maximum, and that's going to be a minimum. Right? Make sense? And I've only got 3 critical numbers, right? And so if I were to do, I mean, if I wanted to connect this with a little sketch, it'd be easy to do.
Need to find like what place there.
You're right, I don't really need to, do I? Because I can see what's going to happen is I'm going to get a maximum here, and I'm going to get a minimum there and a minimum there. And so what's this thing have to do? Right? It's got to do that. And if I look at the end behavior, I can see that, right? As x approaches negative infinity, well, look at my function. As x approaches negative infinity, what's this thing doing? We just look at the leading term, right? Right? So the limit there is infinity, and the limit there is infinity, right? Everybody see that? And so this is definitely going to be the place where these are the places. And what we could test them both, but what are we going to see? It's an even function. And so it's not going to matter if this is positive or negative, is it? Right? It's independent of sign when I plug these in. And so I'm going to get the same values for the distance, which makes sense. It's a symmetrical function, isn't it? Right? And so the winners are going to be there and there. And I think they might want the points. So we just plug them into the function and find the y values, but I don't want to bother with that. Right? I'm bored with it now. That's good. We did the fun stuff. That's just tedious. I don't want to mess with that.
That's the hard question.
Right. So it wants to find the point. So you plug it in.
Just
and
plug
find
it into your
I'd say
calculator,
find
just
the
have
point.
that do all the work.
Right.
Well, both of them are gonna be.
That's pretty cool though, isn't it? Right? We found the place where we minimized the square of distance, so therefore we minimize distance. I think that's a pretty good trick. Okay, let's try another one. Let's do,
A group.
sure, why not? How about this? The product is 185 and the sum is a minimum. That's kind of cool. Why not? 2 numbers. Find 2 numbers that do this. Yeah, you really do, actually. You could maybe, with really convenient numbers, you could probably do something like this without calculus, but it's always kind of hokey. It's a lot of hand waving. With calculus, you get an exact answer, right? So what's our first step going to be? What are our variables? X and Y, 2 numbers. Okay.
X, Y equals 185.
So, yeah. So then our Now what is it that we're trying to, we gotta start with the primary equation. What is it that so I'm not gonna write it down, but x and y, x is a number and y is a number, right? So what is it that we're trying to maximize or minimize? Okay, so the primary equation has to come first, right? What's the primary equation then? X plus y. We'll call it S. S for sum. Right? That's the function I'm trying to minimize. Okay? How many independent variables? So what do I need?
Secondary.
Secondary equation.
X, Y.
Yeah, I need, and the secondary equation, do you remember what I like to call that? Equation of,
Number two. Equation of snapshot.
this is a good way to describe it. Steve,
Equation of constraint.
the equation of constraint, because it's gotta be the constraint.
Yeah.
If there are no constraints on this, what are x and y gonna be if I want their sum to be a minimum?
What is one?
How about negative infinity and negative
Okay.
infinity?
Well,
Right?
You tried.
Cheater.
Right, see what I'm saying? So it doesn't make any sense unless we impose some kind of a constraint on this problem. And the constraint is gonna be the secondary equation. So where does that come from?
X, Y equals 185.
Right? So my secondary equation is x times y equals 185, so what do I do?
Take either X or Y.
Yeah, just isolate y out about.
Yeah.
So y equals 185 over x, right? And now I can rewrite my primary equation as a function of x, right? So s of x equals x plus 185 over x, right? And now we're just gonna do calculus. Oh, and what's the domain gonna be?
All reals.
All reals, right? There's no limits on the domain, okay? And so let's just do a little calculus. What's s prime?
1 plus.
Go ahead.
1 minus 185.
Yeah.
X to the negative second.
Good. Okay, while we're at it, it's easy to do. What's the second derivative gonna be?
1
9 minus, or plus 370 over X.
Right? Okay. And so we could fill in our table. We gotta do a little bit of work here. Is there a value? We gotta find critical numbers. Well,
Zero.
actually, we said our domain was all values of x, but it's not.
Yeah, not zero.
Zero.
There is one restriction here, right? X cannot equal 0. Okay. And that makes sense. Which part makes it impossible for x to be 0? If you just look at the product.
constraint.
Yeah, the product, good. Okay, so then, critical numbers. Are there any places in the domain where the derivative's undefined? Zero's not in the domain, right? So there aren't. So the only place we're gonna look then is for places maybe where the function is equal to 0, right? So if we set this equal to 0, we get s prime equals 0 when, if I set that equal to 0 and add this to the other side, isn't that gonna be when x squared, I just heard it, equals 185? So what's x equal to? Plus or minus square root of 185, right? So in our table then, oops, not y, we called it capital S, right? So we had 0 function is undefined, so what's at 0? Asymptote. And then our critical numbers are at positive square root 185 and negative square root 185. Okay, and those are zeros of the first derivative. Okay, so what are we gonna get for the sign of the second derivative? Well, that's pretty simple. When x is positive, what's the sign of the second derivative? When x is negative, negative. Good. Okay. So then we know that this one is gonna be a maximum, and this one's gonna be a minimum. Make sense? What are we looking for? Minimum. We're trying to minimize the sum, right? Okay, so then, okay, right, so the sum is a minimum. And so this is gonna be the winner right there, isn't it? Right?
Where's the X value?
So that's the x value, right? And so then we're not looking for the value of the sum, we want the y value, don't we? So where do we go?
Back to the original equation.
Yeah, right there, right? Back to our substitution equation. And so, whoops, what's y gonna be? Yeah, what's 185 over the square root of 185? Weird number. That's like 185 to the 1 divided by 185 to the 1/2. To the what? Square root of 185, isn't it? Right? That make sense?
Because, yeah. Yeah, you're a genius.
Right? Doesn't that make sense? This 185 divided by the square root of 185. Well, it's gotta be the square root of 185, isn't it? Right? Because the square root of 185 times the square root of 185 is 185. What do you know? So the square root of 185, those are my two numbers. How about that? So I would say, no, you're not gonna get those without calculus.
So like all those things we did in middle school, we were just doing
Kind of work.
calculus without the actual.
So, wait, so
One
you
down
could,
part.
so since it started out as 185, you just put a square root, and then that would be the answer.
Yeah.
No
Yeah.
calculus needed.
Yeah.
Okay.
No calculus needed. Okay, so so what would they be
No.
for, the product is 16?
Four.
4 and 4. Yeah, that's gonna be it. That's gonna be the minimum. Which makes sense, doesn't it?
Oh, cause that's where it's like,
Yes, that's where it's like.
All right. So.
That was a good day.
That's a real good day, don't you
Okay.
think?
Chicken and car, you know,
Buses.
I can't wait to spend lunch in the library writing